So welcome again to Electrostatics lesson. We are in our second phase, our second lesson, and I would like us to look at the methods in which we can charge a given material. I said in my previous lesson that we have three methods, which we are going to see them right now. We have the induction, we have the contact, and we have the separation methods that we are supposed to use to explain and charge different types of materials. The kind of materials we are going to charge are the ones that has charges, the one that others can use, others can gain. But using the method, we can make a given material to be either positively charged or negatively charged. So there are some questions that we mentioned in our last topic, but we never answered, as to why windows get a lot of dust when they're being wiped. It's because during the process of wiping, the windows acquire charges. They acquire electrostatic charges. It is those charges that will attract a lot of dust. Likewise to your shoes. When they're being brushed, they look shiny, but they have charges, so they will attract a lot of dust. Again, there's another very important question that you always need to ask yourself. Why is it when you are removing a cloth from your body, a nylon cloth, there are a crackling sound and sparks of light? Simply because as you are removing it, the cloth gets charges because it is getting wrapped with your body or with the other part of the cloth. Then when the charges comes into contact with each other is when now you can hear the crackling sound. That's the time you can hear the crackling sound. Remember, from the law of electrostatics, that light charges rebel and light charges attract. So now, the sparks of light you are seeing and the crackling sound is because of repulsion of electrons. Again, you are asked about a precaution that you are supposed to take when you are charging a metallic object. So this one I will explain after we have seen the three methods of charging. And the object to be charged is what we call it a polystyrene ball. We take aluminium foil, then we wrap it on a ball, like this one. It is a polystyrene ball, but the outer surface is wrapped by aluminium foil. This is the kind of a material that we are supposed to learn how we can charge it, how we can make it acquire positive charges or negative charges. That is the process of charging. As far as you can invent a method that you can make a certain object to be positively charged or negatively charged, we call that method of charging. So likewise, now if this one charge here, it has both the positive and negative charges at equal numbers. The protons are always equal to the electrons. But we can look for a way to make electrons more or make electrons less. That is, if I make electrons less, then I'm making the protons to be more. So I'm making the object to be positively charged. So we have three methods. We have induction, we have contact, and then we have method number 3 known as separation. So all these three methods are what we are supposed to discuss right now, in which we can use to charge a polystyrene ball. So let's take a minute, then we look at charging by induction. Charging by induction. Induction is a method of charging that we derive it from the word induce. We derive it from the word induce. Meaning what? There is no contact. There is no contact. What do we require here? We require the material to be charged. We require a charging material. We always call it the charging rod, which can either be positive or negatively charged, depending on your desire. If you want to acquire a positive one, or if you want to acquire a negative one, it depends with the kind of the material or the charging rod that you will require. So now, let's look at this method of charging by induction. Meaning there is no contact. So for example, you want to charge a polystyrene ball like this one. First of all, the stand is on a base, and this one should be an insulator. What is the reason as to why we are putting to stand on an insulator? Is to avoid conduction of charges from the earth or to the earth. So it should be an insulator like a piece of wood, or it should be an insulator like a plastic, and many other insulators that you know. So the first process here, let me start by just using a negatively charged rod. Negatively charged rod. So a negatively charged rod is brought close to it. It is brought close to the material to be charged. Then what happens? Here, you need to be very keen on what will happen here. What will happen is, from the law of charges that states that like charges rebel and like charges attract. This one is a negatively charged rod. When it's being brought close to this material to be charged, what happens is it is going to rebel. It is going to rebel similar charges to the far end. It's going to rebel similar charges to the far end. Then these other sides will remain with positive charges. There is a myth that we need to kill it. Don't ever say it will attract positive charges and repel negative charges. That's a lie, because positive charges can never be attracted nor repelled. So they are only being, what the negative charge is doing is that it is only repelling the similar charges. It is only repelling the negative charges. Then leaving on this side the positive charges. That's what we do. And remember, there is no contact. While the charging rod is still close to the material being charged, we do what we call earthing. We do earthing. That is, we touch with your finger the other side. If the charging rod is on this side, we add the other side. That is, we touch this side. Touching is actually earthing. And this is the symbol for earth. Whenever you see these three lines, which are not proportional to each other, it is a symbol of earthing, meaning there will be an earthing taking place here. I will still talk about earthing, but this is earthing. In the process, during earthing, the electrons can flow to the earth or from the earth. Now in this case, because you are touching a place where we have electrons, it is the electrons that will flow to the earth. They will flow to the earth. And when they flow to the earth, after now touching, you are allowed to withdraw the charging rod. When you withdraw the charging rod, now our final charge will be like this. Our final charge will be like this. These positive charges, which have been left at one side, they do what we call, they redistribute themselves. Remember, I said they are not flowing. The term you are allowed to use is they redistribute themselves. And at the end of the day, this is what is happening. The positive charges will dominate. The positive charges will dominate. And that is what actually would be. So I have used a negatively charged rod and I'm obtaining a positive charge material. That is charging by induction. So you need to know. If, for example, I will use a positively charged rod, I will obtain a negative one. Let me again explain that. So you simply follow the process and understand each step. Now, this is the polystyrene ball. Then I use a positive one. What will happen? From the law of charges, it is going to attract opposite charges, which are electrons. Then what happens to protons? The protons are left on these other sides. The protons are left on the far end. That's how you are supposed to explain. Don't ever say the protons are repelled, because the protons cannot be repelled. They are unrepellable. So then you are supposed to touch now the other side, the opposite side. Touching is adding. Adding is the chain of each electrons from the earth. It can either be gained or it can be lost. When you touch a positive float, like this one, the earth will sense that whatever you are touching is having extra protons. Let me release electrons to come and neutralize. So in this case, electrons will flow from the earth and it will actually neutralize this. And by the end of the day, what we are going to obtain, is now the negative charges will distribute themselves. So you see, I'm using a positive charge rod, I'm obtaining a negatively charged material that is charging by induction. Thank you.